Hello, welcome to EGR-226 Circuit Analysis 2 Lab. This is the co-requisite of EGR-222 Circuit Analysis 2. My name is Gary Millett. I'll be your instructor for this course. Some of you I had last semester, some of you are that unfamiliar. Well, I'm not familiar with you. But nevertheless, hopefully have a good time in this course and it'll be worth your time in a while. So we start the course with an overview and take a look at what we're going to do in the class, and that's this video here. Then we'll do an introduction to Circuit Maker. That'll be our simulation software for this semester. Last semester we used Tinkercad, but it turns out that Tinkercad is limited in what it can do. And so we're going to move up to Circuit Maker, and I'll have to give you a little video about how that works and so forth. And my cat is here. Every time I do a Zoom, the cat finds me. But nevertheless, let's prevail here. So we're going to start the course with an overview of basic electronics, because the first topic, our first lab, is going to be diodes and transistors. And then we're going to deal with op amps later on. So I'm going to give you a little PowerPoint presentation of basic electronics, which you probably will not get in the EGR course 222. Then we'll take a look at op amps, how they operate, and op amp applications. Then we kind of go back into theory, where we'll take a look at phasors and look at resistance and impedance and phase shift. Of course, as soon as we have a component like a capacitor or inductor that is frequency selective, what happens is it turns out that there's a amount of time it takes for that device to either charge or discharge if it's a capacitor, or get energized or de-energized if it's an inductor. And when we combine capacitors and inductors and resistors together, we discover that we end up with phase angles, and we use phasors to describe this. We'll take a look at RLC series resonance. We'll also take a look at LC parallel resonance. Then we jump back to op amps, take a look at some more applications of op amps. We'll take a look at Fourier analysis using Circuit Maker, that is, what frequency components are in signals. We'll actually do a spectrum analyzer and network analyzer lab. Those might be more video displays or video demos that I do compared to what the students might do. However, you can do Bode plots, which are the equivalent to network analyzer outputs using Circuit Maker. And again, the Fourier analysis in Circuit Maker is like using a spectrum analyzer. Then we'll jump back to some theory again. We'll take a look at AC mesh and nodal analysis. We'll take a look at superposition for AC circuits and DC circuits. And then towards the end of the semester, we are going to take a little bit of a look at MATLAB. Oh, there's the cat's tail. And MATLAB will be used to take, and hopefully we'll do some Laplace transforms and some inverse Laplace transforms with MATLAB. At least we'll see demos of that done. And one other topic is power and AC circuits. It turns out if I get an AC circuit, I have phase shifts, I have what's called real and reactive power, and it turns out that's a concept that we should cover. So what happens is the course consists of basically a lab each week. The lab is available, as a document, and it turns out that you can fill out the lab and submit it. There's in the Blackboard website, there's the assignment and the assignment submission area. And so each week you'll be doing a lab and submitting it. Hopefully you keep up with this. Hopefully using Circuit Maker is not too much of a problem. Circuit Maker does not work on Macs. I have explicit instructions in a PowerPoint presentation of how you download it and what you must do with a Windows 10 based machine, doing the troubleshooting compatibility and so forth. So hopefully you're going to have fun this course, and If you need to get in touch with me, the best way to do that is through sending me an email. And otherwise, well, let's get to it.